Hello, everybody, and welcome back. Welcome back. Hope you're all feeling fine. We're going to be starting part C, so these are the questions that are now worth 8 marks. So this is going to be question 21 on our grade 8 Gauss contest from 2012. All three scales shown are balanced. One possible replacement for the question mark is what? Okay. So how can we handle a question like this? Well, the balancing scales are really telling me that this weight is equal to this weight, or this mass is equal to this mass. Okay? And so this is a sneaky way of really just giving me some equations to work with. So that first balance is two triangles weighs the same as a circle. I'm going to fill these in so I don't start confusing the circles with zeros. But that's what the first one tells me. Two triangles is the same as a circle. The second one tells me two squares on one side is equal in weight, or sorry, not two squares, a square and a triangle is equal to two circles. Okay? And what we ultimately would like to know is what are two squares worth? Okay? And there could be lots of answers, but we only have so many presented answers. So what we're going to do is we're just going to look at A and see, is it worth two squares? Is it the same as two squares? B, does that weigh the same as two squares? Now, there's a couple approaches to questions like this. I'll teach you the way that I prefer, the way that I think is the best way, even if sometimes it's a little longer, but it's always guaranteed to work with no real fuss. Okay? Here's what I do with these equations. I just sort of solve for all the shapes in terms of one of them. So here I notice circles are two triangles. Let's get everything in terms of triangles. So how many triangles is a square? How many triangles weigh the same as a square? Well, over here I can say, these two circles are really four triangles. Because we know two triangles is a circle, and I've got two circles. So we've got four triangles are the same as one triangle and a square. If I subtract triangles from both sides, I'll see a square is worth three triangles. Okay? So what are we looking for? We're looking for two squares. That would be the same as six triangles. Okay? So now let's just go through each of our possibilities, A, B, C, D, and E, and ask which one weighs the same as six triangles. And what we're going to do is, no matter what shapes are presented, we're going to change them so it's all in terms of triangles. That makes it very, very easy to compare. So A, a circle and a triangle? Well, one circle and one triangle, a circle is two triangles, so this first one must weigh the same as three triangles. Well, that's not going to work. We need six triangles. So we go to the next one, a circle and two triangles, two circles and a triangle. Okay? So this would be worth four triangles, not enough. How about two circles and a triangle? Well, the two circles is four triangles plus another triangle is five triangles. That's just a little too light to balance with two squares. Two circles and two triangles, three circles and a triangle. It's algebra. It's just we're not using letters. We're using shapes. Okay? So two circles is four triangles plus two more triangles is six triangles. And there we go. That's the one that's going to work. D is our answer. Out of curiosity, E happens to be the same as seven triangles, which isn't going to work. Okay? So this always works, as you can always solve for these shapes in terms of the others. Okay? All you need is the number of shapes needs to be at most one more than the number of sort of balanced equations balanced scales that are presented. But let me show you another approach to this question that's a little more guess and check, sort of a feel your way through the problem. Okay? So we know what? A square and a square, that's what we're trying to balance. Okay? And we know two triangles is a circle And we know a square and a triangle is 2 circles. So here's something we could do. I want to balance 2 squares. Well, I don't know how to balance a square individually, but I know if I had 2 triangles, we'd be all set, right? So here's what we can do. I will add two triangles to both sides. So whatever the question mark is, if I put 2 triangles with the squares and 2 triangles with the question mark, it should stay balanced, right? Okay? But now I can take these pairs of square triangle and square triangle and change them into circles. Okay? So now this is the same as 4 circles over here. Okay? And now, well, a single circle is 2 triangles, right? So we could change one of these circles to 2 triangles. Okay? And get rid of them. Okay? Now I can take those off. And so whatever the question mark is, it's got to weigh the same as 3 circles. Okay? Now, there's not a particular way that I'm approaching this. Okay? It's more me saying, okay, of the answers that I'm given, I don't see any squares, so let's try and get rid of these squares. You can't just get rid of a square, but you can change a square in a triangle. We're just sort of feeling our way through the problem. So now I've got that the question mark is 3 circles. Do any of the answers have just 3 circles? No, E has 3 circles, but it's also got a triangle. So that's not quite going to work. What about any of the other ones? Well, we might try D just because it's got 2 circles. So we've got 1 too many circles, but we also don't have any triangles. Take this circle, change it into 2 triangles, and suddenly we see, oh, okay, D must be the answer. D is the same as the question mark, and therefore D weighs the same as the 2 squares. But this could have gone on a lot longer. There could have been a lot more conversions I have to do. This is not a precise way to approach the question. It's more of a, if you see it, if you can make this sort of connection really fast, that, oh, okay, you add the triangles and you can try and work this down. If your brain makes that sort of connection really well, then you can probably get away with sort of, this is essentially guess and check. Okay? But my preferred way to handle these balance questions when they appear is change all the shapes so they are expressed in terms of one single shape, and then get each of the answers expressed in terms of that shape as well. Okay? Sometimes the guess and check works faster, but sometimes you don't quite know where to go. Okay? I mean, some of you out there may have taken forever to realize, oh, you should add 2 triangles on here so that I can exploit this equation or this scale. Okay? But the convert everything to a single shape, it always works, and it works pretty much always the same amount of time. Okay? So that's why I think that's the better one. That's why we went with that one first. Okay? So that was question 21, a great way to start part C of our paper. Up next is going to be question number 22. So we'll take a look at that in the following video. Take care.